Hi, welcome back to Math with Kim. I am Kim, and I am here to teach you section 6.1, greatest common factor by, and factoring by grouping. So we are going to be talking about the GCF, and we're going to be using factor trees like we've done in the past. So, and again, I have YouTube videos showing you the different ways to use your factor tree. Okay, so here we're going to factor an integer. To write an integer as a product, which means you're multiplying two or more integers. Factoring a polynomial to express the polynomial as a product, again, things being multiplied, of two or more polynomials. Okay, so what they mean by that is here are your integers, okay, and we can find greatest common factor, or of course GCF, right? And here they're talking about polynomials. These are monomials and these are binomials. Oh, can you see these? I know I'm going to have to move this around. I apologize. I wasn't ready to be doing videos today. And number 3 is monomials, and number 4, we've got ourselves some binomials, okay? So we're going to factor all kinds of stuff. And today we are starting with these, okay? So we're going to start with our integers and we're going to do our monomials, okay? So I am going to try to, zoom in, but we will see. Like I said, I'm using a new tool. All right, so what we have is in exercises 1 through 4 notes, identify the greatest common factor. Again, the GCF, okay? And again, we're going to be using factor trees. So hopefully everybody has brushed up on their factor trees. So if we're going to factor, remember we're going to factor with primes. So I always start with, and let me do a quick reminder, primes. Just give you a little list of the beginning primes. Remember, the definition of primes are numbers that are divisible by 1 and themselves only, okay? So 2 is a prime. It's the first prime. It's the smallest prime. It's always the prime I start dividing by, okay? 3 is a prime. 5, 7, 11, 13, okay? So these, you can always start with these, and these are going to help you with most of your problems, all right? So with 12, well, what's the first prime we see that divides into 12? 2. So I'm going to divide out 2 and then times 6. Now, since 2 is prime, I'm going to circle it, all right? Now, 6 is also ready to be factored because it is not a prime, and that's because other numbers can divide into it besides 1 in itself. So again, does the lowest prime divide into it? 2. Sure does, because it's an even number. Remember that 2 divides into every even number, okay? So we're going to divide out that 2, and 6 is 2 times 3. 2 is a prime, and guess what? So is 3. So we're going to circle that, okay? So what that is those are our primes for 12. Now, let's do our primes of 90. So this is our prime factorization, okay? It's 2 times 2 times 3. That's why I circled them, because that's our answer. 2 times 2 times 3. All right. So now we're going to do 90. And I'm going to kind of do it off to the side here, and I'm going to do it in another color. Again, 90 is even. So I'm going to take 2 times 45. I like starting with 2 also because it just splits the number directly in half. Okay. Now I could have done 9 times 10. Okay, I could have done any other numbers that multiply together to equal 90, but I like to start with the smallest primes and work my way up, okay? So anyway, so I'm going to move on. Does 2 divide into 45? No, because this is a prime, all right? Now, does 3 divide into 45? Because that's our next smallest prime. Yes. Now you may have said, well, I know that 5 divides into there. And you're right, 5 does divide into there, 5 times 9, and you could totally do it that way, okay? But I am always going to go up the rank of smallest to largest, because then all my answers will already be in order, okay? So that's just the way I do it. There's other ways to do it. Again, if you want to brush up on your prime factorization skills, go get my prime factorization video and watch it, okay? So 3 divides into here. 3 times what? 3 times 15. 3 is prime. Circle it. Is 15 prime? No, 15 is not prime. All right. Is 15 even? Can 2 divide into 15? No. Can 3 divide into 15? Yes. 15, in fact, is 3 times 5. 3 is prime. Guess what? So is 5. Boom. We're done. Once you've circled your last number and there's no more numbers to break down, you're done. And there's your prime factorization for 90. So that's 2 times 3 times 3 times 5. Now, great, that's wonderful. We broke them all down. What does it have to do with anything? How are we finding our greatest common factor, you may ask? All right, so let me scooch this. I apologize for the weird jumps, but I'd like to get us a little bit clearer here. All right, so what happens is, for greatest common, let's think of that word, common. What do they have in common? Factor. And these are all factors because they're all being multiplied. That's the definition of a factor, okay? So what's my greatest common factor? Well, let's start. What do these guys have in common? Well, this one has a 2 and this one has a 2. So they have it in common. So I write it down once. Now, this one's got a 2. Does this one have another 2? No. So they don't have that in common, so we can't circle it. We don't include it. Well, this one has a 3. Does this one have a 3? It certainly does. So circle that 3. Circle the matching 3. And since they match, because they have it in common, you write it down once. And notice I put a time sign between them because we said these are factors. Factors get multiplied. Okay? So what is our greatest common factor? 6. And what does that mean? That means that 6 divides into 12 evenly and 6 divides into 90 evenly, okay? And that's the largest number that does that together. So, moving on. Number 2. Now, the thing with number 2 is, like they said in the problem earlier about polynomials. Now, these are a monomial, and the reason why it's a monomial is because it's only one term. One term, okay? There's a bunch of stuff being multiplied, but it's still just one term. So let me break these down into their prime factorization tree, okay? We've got the 24, so I'm going to go over here, and 24 is 2 times 12. Kitty's talking to me again. All right, 12 can be broken down into 2 times 6. 2 is prime, circle it. 6 can be broken down into 2 times 3. 2 is prime, circle it. 3 is prime, circle it. Okay, now let's write down our prime factorization of 24. I'm going to write this. I'm going to kind of scooch over a little bit because we're going to need room. So I'm going to do 2 times 2 times 2 times 3. Because that's all the little circled values, right? Now, what I'm also going to include is, remember, when we've got variables raised to exponents, we know we can expand that, right? So that's what I'm going to do. I'm going to expand that a to the third to what it looks like when we expand it. A times A times A, right? And there's a B, but there's only one. So I'm just going to go ahead and put that B there, okay? We good with that? So now this is 24A cubed B in expanded prime factorization, okay? So we broke it all up into all of its pieces. So now let's do that to the 36, okay? So here we go. I'm gonna scooch over a little. We're gonna get us some room over here. So 36 is going to be, again, I start with even, so just 2 is 36 even? Yeah. Does 2 divide into 36? It certainly does. 2 times 18 is 36, right? Now 2 is prime, so I'm going to circle it. 18 is not, so then I've got to divide in my 2 again, because again, I know that this is an even number, so I know 2 will divide into it. So 2 times what? 2 times 9. Circle my 2 because 2 is prime. Is 9 prime? Am I done? No. 9 can be broken up. Can 2 divide into 9? No, because 9 is not even. So we go to our next prime. You should have that written on your paper by now. So 3, does 3 divide into 9? Yes, nice, because 9 is 3 times 3, which means we are done with our prime factorization because we've just ended with 2 primes. So excellent. Now we've got 36 a to the 4th power times b. So I'm going to expand that one. And actually what I'm going to do is I'm going to write it directly underneath so that we can really compare them, okay? So now 2 times 2 times 3 times 3, oop, I'm running into that guy, times, and then we've got, like I said, a to the 4th, so we got to write 4 a's. 1, 2, 3, 4, and we have 1 b, okay? Whew, just staying barely in the stream. All right, so now what do we have in common? See, now when I write them over top of each other, it's kind of easier to see. They have a 2 in common. Hold on. Hang on, I'm going to scooch this up now a little bit. So I can, okay, write the greatest common factor. Greatest common factor. So they have a 2 in common. So I'm going to write that 2 down. And then do they have another thing in common? Yeah. They have another set of 2s. So they both have a 2 in common. So you write it down once. Okay? They have to have it in common for you to write it one time. Be very careful about that. All right. Any more 2s? No. But I do notice they both have a 3 in common, right? So if they both, I could have circled either one, this one or this one. So 3 they have in common, so I'm going to write that down once. Again, remember, these are factors. We put multiplication between them, okay? Now let's start looking at those variables. Well, I see that they have 1a in common. Write it down. They have a second a in common. Write it down. And they have a b in common. So write it down. Okay. So now let's put it all together. So 2 times 2 is 4, times 3 is 12. A times A is A squared times B. So my greatest common factor, it's going to run off the page over here for you, but is 12A squared B. Okay? So, perfect. Let's go ahead and move on to number 3. So 3, same thing, except the problem is there's 1, 2, 3 now that we are working with. Not just 2. So now we're working with 3, okay? So let's go ahead and start our factor trees. Well, first of all, I'm noticing the first one, 27, is definitely not an even number. So 2 will not divide into 27, but will 3? Yes. In fact, 3 times 9 is 27. 3 is prime, 9 is not. But we've already done this, and we know 9 breaks down into 3 times 3, which then finishes our problem, and we've got ourselves primes, okay? So now I'm going to write that down. So my prime factorization for 27, x squared times y times z squared is going to be 3 times 3 times 3, x squared, so x times y, z squared, so times z, okay? First one done. Let's go to do the next one. 6 is pretty easy because 6 is just 2 times 3. Primes, done. So let's write that one down. And I'm going to write it underneath here as the second one, okay? So 6 is going to be 2 times 3, and then x cubed is x times x times x times y times z, okay? Now the last one is now 24. So 24, we've already done that one. By the way, you have it in problem number 2, but we'll do it again for good practice. 24 is 2 times 12. 2 is prime, so circle it. And then 12 is, of course, 2 times 6. 2 is prime, so circle it. And 6, as we've done over and over again, is 2 times 3. Circle, circle. So our last term there is 2 times 2 times 2 times 3 times y times z times z times z times z. So z to the 4th. Okay? All right. So now we're looking for what they all have in common. Well, let's see. Do they all have a 3 in common? Yeah. This one has a 3. This one has a 3. And this one has a 3. Dun, dun, dun. So, I'm going to scooch this down a little bit so I can start writing the answer underneath it for the greatest common factor. Greatest common factor. We just saw that they all 3 have a 3 in common, so we are going to write that down. And then they don't all 3 have a number in common, but they have 2 of them have 2's in common. So is that okay? And the answer to that is no, because if we put a 2 down here where only 2 of them have it in common, 3 times 2 is 6. And if you recall, our first term is a 27. 6 does not divide into 27, so 6 is not a factor, okay? So we only have to do, or we only can include the ones that they all 3 have in common for a common factor, okay? So that's really important because that's a question I get asked a lot. Now, so they have no more numbers in common, so let's start looking at our variables. There's a lot of x's. Do they all have an x in common? No. What's our next variable? Y. Do they all have a y in common? Indeed, they do. So we circle those. We write down our y. Then, do they have a z in common? Yes. They've got, all of them have a z in common. So there we go. So our greatest common factor, 3yz. Okay? All right. Now, last but not least, this is the polynomial. This is the polynomial that is a binomial now, okay? So this is the first time we're working with a binomial. So this is one factor, 8 times the quantity, and this is the second factor, 1 times the quantity, okay? So this is, let me rewrite this. So this is the first factor. Now I could write the factor tree of 8, and that's 2 times 2 times 2. I'm just going to write the prime factorization, 2 times 2 times 2, and 2x minus 3. We can't break anything up inside of parentheses, okay? Now the second binomial is 1. So I'll just put a 1 out here, even though I don't normally put a 1, but that's got our 1 on the outside, and then that's times 2x minus 3. Well, what do these two have in common? They have the binomial in common, and that's the only thing they have in common. So what is their greatest common factor? The binomial. They have this in common, and that's it. Well, I guess you could put the 1 in front of it, but you don't do that. Okay? So that's number 4. That's how we find our greatest common factor with binomials included. We just do the same thing. We do our prime factorization and we see what they have in common. So that is the end of the first part of the notes for 6.1. Okay, and the greatest common factor. Okay, so the next video is going to be the second half of this, which is factoring by grouping. Okay, so I will post this video, and then the next video starts on, I'm trying to get the piece of paper for you to see, starts right here at the top about talking about factoring out greatest common factor, and then it goes into using distributive property, and then factoring out the greatest common factor. All right. And then this is where we will be done.